Hello everyone, this is my video solution to the ICPC 2017 problem number 1 called Latin squares. And so the premise of this problem is that you're given input that looks something like this, like just a bunch of random numbers and some letters in there. And so what you're supposed to do, what these numbers represent is something called a Latin square. And what this program that you write is supposed to do is supposed to determine whether or not these numbers constitute a Latin square or not, like whether they actually are a Latin square or whether they're just a random set of numbers. And so the first number represents the base counting system for that number of preceding lines. So this number is 3. So the next 3 lines are that Latin square, and the each number, so 0, 1, 2, represents a number in base 3, not base 10, like we usually just think of. And so what you're supposed to take these inputs. So you take the first number, you grab the next 3 lines, and determine whether each line has every number appear exactly once. So 0, 1, and 2, 1, 2, 0, or 2, 0, 1. So every line in every row is supposed to have those numbers appear exactly once. So in this case, a little more visual way to kind of think about it would be this, where every row and every column has the numbers 0, 1, and 2 appear exactly once. And again, these numbers represent base 3, and so that's what a Latin square is. And another thing you're supposed to figure out is whether or not this Latin square is reduced. And the Latin square is reduced if in the first row and in the first column the numbers appear consecutively. So what I mean by consecutively is they go in order. So the first number would obviously be 0, and then the second would be 1 because it's the next number after that. So the first row is reduced, the second row is reduced, and so the Latin square overall is reduced if the first row and the first column are reduced. And so that's the premise of the problem. Again, you're just going to take input. The first input tells you the base as well, how many rows and columns that you have to take into process. So the first number is 3, so I'll take in the next 3 rows and process those. The first number is 4, you take the next 4. The next number is 11, so you'll take in the next 11. And you'll see here, if you don't understand what I mean by base, I mean, like, see how it says 11. So the next 11 rows and columns are in base 11. So you'll see how there are A's. That's because in base 11 you don't have 10, you have A. So it'll go from every number 0 through 9. And then it'll also have the letter A to represent 10 in base 11. And so that's the premise of the problem. You're just going to take, again, you're going to take that input, you're going to take those next 3 lines of input, and you're going to process that to see if they're a Latin square. In this case, it'd be the next 4 lines because it's in base, it's the number 4. You're gonna process those in base 4 and see if they're Latin squares, and if they're reduced, again, 11, next 11 lines, and you're gonna process those to see if they're reduced and if they're Latin squares. So if we go to my solution, the first thing I did was just create some variables that I'll go through as I'm explaining the solution. Obviously, some things are kind of self-explanatory, where sum and temp sum 1 and temp sum 2 represent the summation of values, which I'll tell you what those values are later on in this video. The base, like I said earlier, the first input is obviously going to be base 3 because again, that represents the base numerical system that you're counting in. So 3 would represent base 3. You take in the next 3 rows, and so every number again is in base 3. So 0 isn't in base 10, it's in base 3. The 1 here isn't in base 10, it's in base 3. For this 11 one down here, where you just see a bunch of numbers and letters, this A isn't the character A, it's actually the number 10 because we're in base 11. So again, that's what base is supposed to be. Is a Latin square and is reduced. Again, those are just variables. Those are just Boolean values to see if we've determined whether or not they're Latin squares or reduced. And so this map right here that I created, the letter to int unordered map, it's just a way of me to keep track of the different base systems. And so You'll see in a minute what I mean by that. And again, these output and input streams are just to write input and output. And this is just me opening the stream, making sure everything worked correctly and whatnot. And so this here is to find every value in the alphabet. So say, for example, right, this was base 11 and we had the letter A in here. In order to process Latin square, we have to think of it in terms of numbers, not characters, because again, these aren't bases. These are different bases, so they are numbers. It's just we have to process them as so. So what I did was I created a map that takes every character, right, starting at 65. So see how it started at 65. So we're gonna take every character starting at 65 and turn that into a number. And so if you look up an ASCII table, you'll see that 65, right? 65 represents the letter A, the letter A. So the decimal value 65 represents the character, the letter A. So what I did was I created a map that takes the every character value. So it'll take the character value of 65, which is again the letter A, and it'll map it to the number 10, because again the first base that we start seeing letters on is base 11. So we'll see the letter A appear to represent 10, because again base 11 A is equal to 10. So my logic is that if we're in any base greater than 11, greater than or equal to 11, A will always represent 10. So just writing it out, what I'm trying to say is if you're in base n, any n greater than or equal to 11, A will be equal to 10, base 10. So if you're in base 15 and you see the letter A will still represent 10. Or if you're in base 27 and you see the letter A still represents 10. If you're in another example, if you're in base n where n is greater than or equal to 12 and you see the letter B is equal to 11 in base 10. So if you're in any like base 15 or base 30 or any base greater than or equal to 12, B will always represent 11. So what I'm trying to do is I'm trying to create a map here that essentially takes every character value and maps it to its to whatever number it is in any base up to 35. And so this while loop here is just me taking every input and every line and processing them. This is where the actual processing goes through, and where we check to see if everything's a Latin square or if everything is reduced. So this first while is just input.eof. EOF stands for end of file. So while the input is not at the end of the file, just keep processing input. So that's what that is. So I'm going to grab the first input and I'm going to take that input and pass it to base. Again, base represents the base counting system that we're in. So the first base that we're going to be in is in base 3. And so I created a square to represent, again, the visual way of seeing it is I create a square, a multi-dimensional array that holds those values. You can think of it, that multi-dimensional array, like a square. So our first base is going to be a 3. So I'm going to create a 3 by 3 square to hold the values of that supposed Latin square. And so this sum, I don't know if any of you may be familiar with the summation equation. So if you're trying to add every number 1 to some number n, this equation is what you could use to find them. You could use the summation equation to find that sum instead of counting each one individually with a for loop. So because we only ever get to that value up to the 1 minus the base, I did 1 minus the summation equation. So it would be, instead of, if you're familiar with it, the equation is n times n plus 1 times all over 1/2. But in this case, since we never actually get up to n, which in this case would be the base, I subtracted 1. So instead of n times n plus 1, you subtract 1 from each n. So it's, instead of n times n plus 1, it'd be n minus 1 times n times 1/2 to find the summation of the first of those first single digit numbers in that base. For example, if you were in base 10 and you wanted to find the numbers in all the summation of the single digit numbers in base 10, this would be the equation you use. So we're in base 10, so 10 times 10 minus 1, which is 90, right? 10 times 10 minus 1, which is 10 times 9, which is 90, all over 1/2, which is 45. So if you add all the numbers 1 through 9, which are again the first single digit numbers in base 10, you get the number 45. And so I'm just finding the summation of the first single digit numbers in any base. And I'm just keeping that in a variable called sum. And this will actually come in useful later, because if you think about it, if you have a Latin square and every number appears once in every row and every column, then every row and every column should add up to the same thing. So if you have 0, 1, and 2, or 1 and 2, 0 in any row in any column, all the numbers will add up once. All the numbers will add up to the same sum no matter what. And that sum would be the base times base minus 1 all over 1/2, which is why I'm keeping track of it. And so again, this is me just grabbing after I grab the 3. So after I grab the 3, I'm going to grab that 0, 1, and 2. So I'm going to grab 0, 1, and 2. And then this is me just turning that line 0, 1, and 2 into a bunch of characters, into a character array. So instead of being one string of 0, 1, and 2, I turned it into a character array of 0, of 1, and of 2. Instead of one giant string, I just made it into a bunch of characters. And then I'm going to go through that character array with this for loop here. I'm going to go through that character array, and I'm going to go through each character, and I'm going to check if that character is a letter or not. So again, this is useful because when we get to higher bases, any base greater than 10, you'll eventually start seeing letters. And again, we have to think of those letters as numbers, not actual letters for our program. So I'm going to just check if those characters are letters. So if 65 is less than a temporary character, temporary temp char, or is less than, if temporary character is greater than or equal to 65 and less than 91, then we know it's a letter. And if you look back, the reason for that is because 65, right, that's the letter A, the decimal version of 65. And if we go to 91, that's where you see that it's not a letter anymore. So you have to be less than 91 and greater than or equal to 65 in order for you to be an actual letter. So if you're a character and you want to be an actual letter, you have to be within that range. And so if it is a character, if it is a letter character, so if it is some A, B, or C, or just any letter in the alphabet, I'm going to go ahead and grab the numerical version. Again, I made a map, if you remember the map letter to int, where I just turned every character value that is a letter into some number. I'm just going to grab that number. Letter to int goes to that map. When you pass in if you pass in temp char into letter to int, it's going to grab the numerical value that's associated with that letter. So I'm going to go ahead and put that numerical value into our two-dimensional square array. And if it's not a letter, then we know that it represents a number, because the only time you're going to see in this program something that isn't a letter, if it's not a letter, then it's a number, because it's 0 through 9 and A through 35. A through Z. So you'll only see the only characters you'll see are A through Z and 0 through 9. And so if it's not a letter, then it must be a number. And so this line here is just me taking that number character, turning it into an actual integer, and passing that to our two-dimensional square array. And so now that we have all the values in a base 10 system, that now we can usually just think of just fine, because we count in base 10. So now that I've taken all those numbers, now I can go ahead and process the information we have see if it's a Latin square or not. So this part of my program here checks if it's a Latin square or not. And so the first line, I'm just going to go ahead and assume it is Latin square. I'm going to go ahead and set that to true. And the only thing that's going to change that is this for loop here, which has another for loop inside of it. So when that first for loop goes through, it's going to set temp sum 1 and temp sum 2 equal to 0. And temp sum 1 is just going to keep track of the summation for every row, and temp sum 2 is going to keep track of the summation for every column. And so temp sum 1, again, this second for loop is just to go ahead into every specific index in our two-dimensional square array, grab that value, and just add it to temp sum 1 to keep track of the sum for a row, and temp sum 2 to keep track of the sum for a column. And then this if is just going to see if the temporary sum is not equal to sum, right? Because if it's not equal to sum, that means some number appears twice, and it's not a Latin square. So if it's every number doesn't appear exactly once in our Latin square in every row and in every column, then it's not going to add to sum. And if it's not equal to sum, then we know it's not a Latin square, and we're just going to go ahead and break out of the for loop with this break. And so again, this right here, it's only going to happen if the temporary sums don't add to what they're supposed to add to. If they don't add what they're supposed to add to, then you know it's not a Latin square. And this next part of my program, this for loop here and this variable is reduced. So again, is reduced is just going to be set equal to true in the no matter what. I'm going to assume it's true, and the only thing that's going to change that value is this for loop here. That could possibly change that value is this for loop here. So again, we know it's reduced if the first row and the first column have every number appear consecutively. So in the first square, in the first Latin square, it's the number 0, 1, and 2, and 0, 1, and 2. So the first row and the first column have to be 0, 1, and 2. So this first row and first column, all the numbers have to appear. All the numbers have to appear consecutively. So this is the first one is 0. So the next one has to be 1 in the row. The one after one has to be 2, and the same logic follows for the column. And so if I just go to my program, it's going to check if so this first if is just to check the rows. So if the first value is not equal to the next value, or is not the first value plus 1 is not equal to the next value, because again they appear consecutively. So these so if you add 1 to the previous value, it should give you the current value. So let me just zoom in. Ooh. So if I zoom in here, you can see that better. So if square is 0, again, this is the first row, and we're going to grab that first character with I minus 1. If you grab that first number with I minus 1, and we're going to add 1 to it. And if we add 1 to it, it should equal to the next number in that row. And if it doesn't equal that next number in that row, we're going to just set it equal to false. And we know it's not reduced, and we're just going to break out of the for loop. This next if does the same logic, except for instead of a row, it's for the column. So instead of checking whether the first value is equal to the next value in the next row, we're going to check if the first value is equal to the first value in the next column. So we're going to see if this number here is equal to is 1 less than this number here, and we're going to see if the second number is equal to 1 less than this number here, which is the kind of logic that I'm following. And so this if just goes ahead and just prints out to my files. So if it is not a Latin square, we're just going to write out no to mean no, it's not a Latin square. And if it is a Latin square, we're going to go ahead and ask ourselves, is it reduced? So if is reduced, we're gonna just output to the file reduced to represent, yes, this is a Latin square and it is reduced. And if it's not reduced, we're going to output not reduced to represent no, it is a Latin square, but it's not reduced. And so that's the end of my program here. And if you look at my output, currently my output has nothing in it. This is my input. And when I run my program, it does everything for me. And then if I go to output, it now has reduced, not reduced, and no. And if you look at the problem, look at the sample output for the sample input, which is this, you'll see that this is what you're supposed to get: reduced, not reduced, and no. And that's my solution to the ICPC 2017 problem number 1 Latin squares.